Hello everyone, I'm Haritha from Dr. Dong's research group and I'm going to be presenting my work entitled Self-Assembling Peptides with Internal Ionizable Unnatural Amino Acid Toward Application from Targeted Therapy to Proton Transport. pH responsive nanomaterials are used for a range of biomedical and biotechnological application, but tuning the pH responsiveness using natural amino acid is not trivial because their intrinsic pK is far from biologically relevant pH, except histidine which has a pK of 6. Previous studies shows that many protein contain ionic acids in their interior and their pK values are different from solvent exposed region. Inspired by this, we aim to synthesize a new family of pH responsive materials based on self assembly of peptides with tertiary amine containing unnatural amino acid. So, previous study from our lab shows the peptides with alternating leucine and glutamine drives the formation of sandwich-like nanofibers. By introducing histidine to this sequence, we have showed the synthesis of pH responsive peptides which has antimicrobial property. So there's a need for new design and synthesis of known natural amino acid that can present chemically diverse ionizable side chain for the construction of pH responsive materials with enhanced pH tunability. So in this work, we synthesized two unnatural amino acids with tertiary amine group. Compared to lysine, these are more hydrophobic, therefore could be better accommodated in the hydrophobic compartment of self-assembled peptide. Then we introduce this residues in the multi-domain peptides, which is known to form beta sheets. First, we conducted pH titration experiment to find out the pK of these peptides. We found that PEG K did not trigger the self-assembly and no apparent pK was identified below 8. But other two peptides with no natural amino acid shows the buffering range between 5 and 6. From Hill plot, we observed that peptides with XB substitution has stronger cooperativity. So for further study, we decided to use XB. We also used CD and TM to monitor the secondary structure change of PEG-XB as the function of pH. CD data shows the transition from well-defined beta sheets to random coil as the solution acidifies. From TEM images, you can see elongated nanofibers at pH 7.4 and the reduction of pH to 5.5 shows a disassembly of majority of peptides. So then we used NMR spectroscopy for solution studies. The addition of sodium tetroxide triggered the self-assembly, which led to the suppression of NMR signal for all protons. We performed analytical ultracentrifugation to determine the molecular weight of the species formed. Here we modified the peptide sequence by incorporating lysine in the N-terminus to increase the solubility because PEG-XP was becoming cloudy with time during the study. So based on the sedimentation traces at pH 7.5 and 6.5, formation of large species was observed. At pH 5.5, AUC shows predominantly monomers with molecular weight of 2.8 kilodalton. Taken together, these results show importance of having ionizable amino acids in the hydrophobic core. Then we tested the antimicrobial activity of K4G5XB against E. coli. The MIC of K4G5XB was found at 2.5 micromole, which is 4 times lower than most potent histidine containing peptide. And then we used bacterial live and dead assay of E. coli to confirm antimicrobial activity. We observed significant bacterial death at pH 5.5, but at higher pH, we did not see any antimicrobial activity. And we also found that these peptides show good cytocompatibility with IC50 around 80 micromole. In conclusion, we demonstrated the synthesis of tertiary amine containing unnatural amino acid. We incorporated these amino acids into multi-domain peptides and we used CD, AUC, and TM to characterize the pH dependent self assembly. From the preliminary antimicrobial studies, acidity triggered antibacterial properties are observed. So, for the future work, we are planning to extend the known natural amino acid library and we'll be also expanding the library of MDPs containing various XB and XP analogs at different sites of different amphiphilic uh, peptides. And we'll be also studying the pH responsiveness of these peptides. We'll also use pH responsive peptides for proton transport studies. Thank you.